What's up guys, I hope you're doing great. This video is all about understanding what explicit actually is in modern C++. To understand explicit, let's just talk about implicit and explicit keywords for a second. Well, we do not have an implicit keyword, but the idea of implicit basically is that we do not tell the compiler what it is supposed to do exactly, and then it does things on its own. Whereas explicit actually means we tell exactly what to do. Now, this sounds random, right? But we'll have an example where we illustrate the idea of explicit keyword and then you'll understand what I'm talking about. The thing to remember is that C++ compiler is actually allowed to perform one implicit conversion from one data type to the other to make the code run. That means if you have a variable and let's say your code requires it to be casted to another type, if it's possible, the compiler can do it automatically once, but not twice for the variable. Now let's code an example and then things will become super clear. Here we have our boilerplate code and we will exhibit the idea of explicit keyword using an example here. So let's make a class human for our example, which will have two member variables, one for name and the other for age. So let's have private and public members. Okay, perfect. So for private, let's have std string name and int age. We need to have a constructor. So let's have a constructor. Let's have a constructor where you can only give the name and not the age. And this is your initialization list. Name and age will be, let's say, -1 because we haven't given the age. Okay, so this is your constructor. Let's ignore this squiggly line for now. It is there for a reason and then we'll talk about it in a bit. Let's have another constructor which takes only the age and not the name. Let's say int age, name none, and age will be age. And now what we can do is we can use this class right now. We'll have human a. Let's just give the age right now, which is, let's say, 10. We can also use the other constructor by only using the name. So let's say human b, the name. Okay, let's see if everything is fine. Everything is fine right now. Now we can actually do the same thing in another interesting way. Let's look at this. This looks weird, but this works. Yeah, see, it does. So what's happening here is the compiler is taking the number 10 and then it is typecasting it to an object of the class human. We discussed before that the compiler is allowed to perform one implicit conversion, and this is exactly where the idea of implicit comes in. Now this was the case where an implicit conversion was happening, and we can of course do the same with human b, right? Let's see. So this actually did not work. Right, so why did this not work? That is because this is not string. This is a char pointer. So the compiler has to convert char pointer to string, which is fine. That is the first conversion. Now to make the object of the class human, it has to perform a second conversion, which is moving from string to an object of class human. But the compiler is not allowed to do a second conversion for this variable. That's why this fails. How do you fix this? What we do is we manually typecast it to std string. Now everything works, right? Because we've already typecasted this char pointer to std string, and now the compiler has to do only one implicit conversion. So now it's converting from std string to an object of class human. So everything works here. Let's also check. Okay, everything is working here. So this was a demonstration of your implicit conversion, and that is where the idea of implicit comes in. I personally don't like to initialize these objects this way. I would rather do this, which is what we all know already, because this is cleaner. I like this a lot, but using this just simplifies the code. Sometimes I personally do not prefer it anywhere in the project. But the thing is, if we want this functionality to be disabled and we do not want any implicit conversion like this, we can use the keyword explicit. Now let's try the word explicit here. So this keyword explicit for your constructor. See, you have an error on line 23. We can also have this explicit keyword here, right? So you cannot run this anymore, right? So what has happened here is when you use the keyword explicit for this constructor, it tells the compiler, no, do not perform any implicit conversion. You have to use the constructor as it is. So that disables this functionality of implicit conversion. You can find this explicit keyword there in most projects where you are using a constructor with only one argument, and I like to use it all the time. If we remove explicit for a minute again, let's see. We have this squiggly line again, right? And I previously did not tell you what that squiggly line is all about. Let's look at this. It actually says that class human has a constructor with one argument that is not explicit. So at least from what I understand, this is a good practice. You should always have explicit when you're using one argument for your constructor. One argument for your constructor. And that is something I use all the time. So I hope you understood the idea of explicit keyword, the idea of implicit conversion, where the compiler can perform one implicit conversion without us saying anything. If you have any questions, do let me know in the comment section. I'll see you in the next video. Thank you so much for watching, guys. Bye-bye.